All right. So today we're going to be looking at an introduction to probability of mutually exclusive and independent probabilities. So let's just get started with the basic definition of probability. Okay. So P of x, which is the probability of an event, x is an event that's happening, is equal to the total possibilities or outcomes. You'll hear that also. Over on the top is your desired event. Okay, so there's lots of different ways to write the definition of probability, but this is basically what it is. Now just note, a probability, P of x, has to be between 0 and 1. So it can actually also be 0 and be 1. If the probability is 1, it means it's a 100% chance that it will occur. The probability is 0, it means it will not occur. For example, if you have a bag of marbles that is all blue, and you ask the question, what is the probability of selecting a red a red marble from that bag? It'll be 0, because there's no red marbles in the bag. If you ask the question, what's the probability of selecting a blue marble? It'll be 100%, because the bag is full of blue marbles. Let's look at mutually exclusive events right now. Okay, so let's say we have a set. So S is called the universe of possibilities. So let's say I have set of two different values of dice numbers. So this is my evens, this is my odds. So on a dice, there's 2, 4, 6, and 1, 3, and 5 equals a 6. So I have an even set and I have an odd set. And notice that in my universal set, so the S on the outside is known as the universal set. Has all the numbers, has 1, 2, 3, 4, 5, and 6. Those are all numbers in this universal set because those two sets are in that rectangle. So these two are mutually exclusive because, let's write that down. These are mutually exclusive. Events, because you cannot be even and odd at the same time. You can only be one or the other, this or that. So think mutually exclusive is this or that. So let's calculate the probability here on the next slide. Let's find the probability of an even number or a 1. Okay, so the question is, what is the probability that you roll an even number or a 1? Okay, so what we're going to do is find our favorable or desired outcomes. Okay, so you'll see desired outcomes, you'll see desired events, lots of different ways to write it. You'll see number of favorable outcomes, and on the bottom is the number of total possibilities. Okay. All right, so on the top, and we can also break this up into two parts as well. So we can kind of do this first one, probability of even or 1, kind of break it up into 2 different fractions and just add them together. So both the fractions are going to have the same numerator and denominator info. So let's just do that. Probability of even, I'm just going to put even here. So let's see. The number of evens is 3 out of 6 total. Then we can do plus the probability of a 1. And there's only a 1 value that meets that criteria out of 6. Okay, so the probability of even plus the probability of 1 is equal to 3/6 plus 1/6, okay, which will give us 4/6 or 2/3. Okay, so, and these, you're not going to have to subtract anything out here because they're not going to overlap. Now, if the events overlap or they depend on each other, you'll have to do some subtraction. And if there's any common similarities with those, you'll have to subtract. But here, these are mutually exclusive events, so we don't have to do any subtraction. We just find the event of one plus the event of the other one. Okay, let's look at another one. So let's look at this another mutually exclusive event problem here. I think on this video I'm just going to focus on mutually exclusive events, and then we'll do another video on independent events. So what's the probability of even and 3 is the question. And we're still looking at that set from earlier that are mutually exclusive events. So I had 2 sets in my sample space. I had 2, I had a 4, I had a 6, I had a 1, I had a 3, and I had a 5. So there's no overlap here. And what I mean by overlap is if you have another set of Venn diagrams, there could be an overlap in there where numbers are in common or values or elements are in common. Here these can't be in common because one's even, one's odd. So the question is, what's the probability of an even and it being 3? So what's the probability that you roll an even and a 3? Okay, so there's no way to do this. The answer is 0 because my desired events over my total possibilities. Okay, so my total possibilities, if I did this at the same time, there's going to be 6 numbers I can choose from. The numbers that are both even and a 3, that's 0. You can't be a 3 and be even. Okay, so this answer will be 0 here. So that's one of the keys for mutually exclusive events. If you're trying to do a combination of both of the sets, your answer will always be 0 because there's no overlap in between. All right, let's just talk about one more thing here. Let's talk about a complement of a set. And I'm sure you've heard this before. A complement of an event. Okay, so basically, let's say I have this set here. Okay, so I have my sample space. Maybe in my sample space I have a $sign. Let's actually make it numbers. So I have a 1, I have a 2, 3, 4, 5, 6, 7. So I have those 7 values. Then I have a set within my sample space that has, let's call that set A, has 3, 5, 6 in there. So if I want to find the probability of selecting a 3 or a 5 or a 6, okay, so if I wanted to find the probability of getting a 3 or a 5 or a 6, I can find that probability pretty easily. So there's 3 of those possibilities, so that my desired events are 3, those 3 numbers that I want, over my total possibilities. So all the total possibilities are in your set S, your universal set. So 1, 2, 3, 4, 5, 6, 7. So that's my probability. Okay. Now, that's not the complement. That's just the basic probability that you know how to do. The complement is basically the numbers that are not in that set A, or not in that probability that you want. So the complement, okay, so sometimes people write the complement as, okay, so I'm going to do 3, 5, 6. Sometimes people put a complement like that on the probability, so you know it's not selecting that probability. Sometimes they just write what's the complement in words. Okay, so to find the complement, I figure out what numbers are not 3, 5, and 6. So the numbers that are not 3, 5, and 6 are 1, 2, 4, and 7 there. So there's 4 possibilities out of the 7. Okay, so this in yellow is the complement. Okay, that's the complement. And orange is just the probability of those 3 values. Now here's something you should put in your theorem book. Okay, so the complement of an event X, so see that line over the top? Okay, the line over the top means it's a complement of a probability, is equal to just 1 minus the probability of that event happening. Okay, the reason why it's 1, because there's 100%. You always use 100% of all the probabilities. So in the last example, we found the probability of 3, 5, 6 was 3/7. Okay, so if we wanted to find the complement of that set, it's actually really easy once you know this formula here. Okay, all we had to do was just do 1 minus 3/7. Okay, that's all we had to do here. And when you do 1 minus 3/7, we would have gotten the value 4/7 if you did a common denominator of 7/7. Right, that 1 could be 7/7. Then you get 4/7. So this video was an introduction of mutually exclusive events and complements and probabilities. The next video we're going to look at independent events.